Hello, my name is Cody Walker, and this is my presentation about collision of small masses, particularly two little toy cars. So this is the introduction to my experiment. My experiment was conducted with two toy cars and a ramp. I have a red car and a yellow car. The red car had a mass of 38.8 grams, and the yellow car had a mass of 34.6 grams. The ramp I used, there was two ramps. There was one that was flat, and then there's another one on an incline. And the car will go down the incline onto the flat ramp and collide with the other car. The ramp was constructed of cardboard, some glue, and some paper to smooth out the surface. The camera used to record the video of the collision was leveled using a leveling app on my phone. And I used the slow-mo option on my camera, and I had the phone face down on the table with the camera sticking out the edge so it could record the collision. So this is my video of the red car colliding into the yellow car. The yellow car is sitting there right on that black line. That black line represents 12 inches away from the end of the ramp. So the red car is going to come, collide into the yellow car like that. Play it again. And that is the collision of the red car into the yellow car. There we go. All right, so this is the analysis of the video. So I went into Tracker and I tracked each individual car. I tracked the red car before it collides into the yellow car. I tracked the yellow car after the collision, and I also tracked the red car after the collision as well. So this is the red car before the collision. This is its position on top and its velocity underneath. And these are each before the collision. There is some loss in velocity due to the ramps, the angles that the ramps were placed. It made it so where when the car exited off the first ramp onto the second, there's a little bit of a lip, and it caused a little bit of loss in velocity, I could kind of tell. But the kinetic energy is 1/2 mass times velocity squared, and I had to convert the velocity, because I measured this in inches per second is what the velocity is measured in, and I had to convert that into meters per second. So after that, the kinetic energy was 52 joules. Also, the ramp was at an angle of 31.6 degrees to the ground. This is the position and velocity of the yellow car after the collision. So the red car runs into the yellow car, and then the yellow car rolls away. The yellow car takes 0.3 seconds to travel 12 inches or 1 foot. And the kinetic energy of the yellow car is 18.2 joules. This is the red car after the collision. So the red car runs into the yellow car, and the red car still keeps rolling a little bit after the collision. Not very quickly though, because we see here after the fact that the kinetic energy of the red car previously was 52 joules and is now 21.1 joules. So a lot of that energy was converted into the yellow car to push it forward. So you can kind of see a curve here on the position graph. And that curve towards the top, that is the deceleration. It's already decelerated quite a lot because of the collision, but it continues to decelerate due to friction. So this is the yellow car into the red car. So this is the same thing as the same ramp and same measurements and everything. The only difference is the roles are reversed. So the lighter object is now running into the more massive object. And that is the yellow car running into the red car. I'll play that one more time. You see the yellow car come from the left, hit the red car shoots off to the right. Okay. So this is the position and the velocity graphs of the yellow car before the collision. Again, some velocity is lost due to the angle of the ramp. And you see here the slope of the position graph is 62. So that's about what velocity it was going and the average velocity of it. And once again, you take that velocity is in inches per second. So we convert it to meters per second and square it and multiply it by mass and times 0.5. And that is 44 joules. So the kinetic energy of the yellow car before the collision is 44 joules. And this is the position of velocity graphs of the red car after the collision. The red car is more massive than the yellow car. So in the previous experiment, that helped. The red car was more massive, so it pushed the yellow car further at a faster rate. Now the roles are reversed. So the lighter object is trying to push the heavier object. So the kinetic energy of the red car after the collision, so the yellow car runs into the red car, kinetic energy of the red car is 10.9 joules. So these are the position and velocity graphs of the yellow car after the collision. So after the yellow car runs into the red car rolls off. Now this is the yellow car. So you see here again, you have your curve on the top graph. You have a curve showing the deceleration, just like in the previous experiment. And you see down on the bottom, the velocity is less and less. It's going down because it's slowing down due to friction. And the kinetic energy of the yellow car here after the collision is 7.2 joules. So some comparisons between the experiments. Well, about the same energy was lost. You could say, because these energies aren't very high, but in reality, it's about half. The red car colliding into the yellow car lost about half as much energy as the yellow car into the red car. And that's due to the difference in mass. The red car started with 52 joules, and then it ran into the yellow car. And then in the other experiment, the yellow car started off with 44 joules, and it ran into the red car. Yellow car running into the red car lost about 25.9, while the red on yellow lost about 12.7. So in conclusion, your key takeaway here is mass matters. Whenever you have a collision between two objects, your mass matters. And that's the key takeaway from this experiment. Thank you for your time, and that'll be all.